This is Megan Adekary from Lab Section M01, and I will be discussing Lab 5, the motion of falling objects. For this lab, I videotaped two objects falling, a tennis ball and an empty rosin box. I then tracked the motion using Tracker and then used VPython to predict and model their motion, first with gravity alone, then with gravity and drag. This resulted in showing that for heavier objects, the force of drag is negligible compared to the force of gravity, and that just as before, we can use the momentum principle to predict the motion of a falling object. So here are the two clips. This is the tennis ball. I set the axis so that the ball is falling along the negative y-axis. I then set the calibration stick to a length of 0.067 meters, which is the diameter of a tennis ball, which I looked up online. I then tracked the ball from clips 5 through 20 for about 0.63 seconds when the time between each clip was 1/30th of a second. And this is what the tracking looks like. Similarly, I set the axis for the rosin box the same way, with this being the negative y-axis. I then set the calibration stick to 0.05 meters, which was the width of the box. The box was then tracked for about 0.67 seconds, where the frames being 1 through 18, where the time between each frame was also 1/30th of a second. And this is what it looked like. Afterward, I modeled both objects in VPython. To model the objects, I first found their masses online, where 0.0577 kilograms was the mass of the tennis ball, and 0.00025 was the mass of the rosin box. I then inputted the initial position, which I took from Tracker, and using an initial velocity of 1 in the x direction and 0 in the y direction, and a small delta t to predict the motion. I then predicted the motion when gravity is the only force, where gravity equals negative mg, which is the mass of the ball times the force times gravity, which is 9.81, and F net being the force of gravity plus the force of drag, where the force of drag is 0 in this case. So this is the model of the tennis ball when gravity is the only force acting upon it. And as you can see, it's also very parabolic, and the red arrow represents the force of gravity. And this is the model predicted by VPython for the rosin box when gravity is the only force. I then modeled the motion by adding a force of drag, specifically viscous drag, which is proportional to the object's speed but opposite the force of gravity. I then played around with the constant of proportionality so that the model could be as accurate as possible. This resulted in a constant of 0.045 for the tennis ball and 0.00001 for the rosin box. And so this is the model that they predicted for the tennis ball when both gravity and drag are acting upon it, with the green arrow being the force of drag. And this is the model of the rosin box with both gravity and drag. I then graphed all the data from the actual object and the two predictions and compared them. For the tennis ball, the model with the only gravity fell faster than the actual ball, and then the prediction with drag was more accurate but fell much faster initially than the actual ball. However, both predictions for the rosin box were fairly accurate except towards the end. These results, however, actually do not fully support the idea that for heavier objects the force of drag is negligible, but the shape of the object may have been a cause for that. So what does this all mean, specifically for the rosin box? Well, if we look at the graph of the data, we see that is parabolic, implying that the velocity of the box is changing, specifically increasing as time increases, and becomes almost linear towards the end, indicating a possible terminal velocity, where the net force is equal to 0 and velocity becomes constant. But now the question is, what if the object did not start from rest but was thrown down? Well, the net force would now have to include the initial force given to the object, and the object would fall faster initially when dropped. Would the object ever reach terminal velocity? Yes, if the duration of the fall was long enough to allow for the force of drag to equal the sum of the force of gravity and the initial force. But for most objects that are thrown down a short distance, this will probably never occur.